All right, so abstract data types. That's a kind of vague term. It's a data type that specifies values that can be stored and operations that can be done on the values. Sounds like a class, really. A user of an abstract data type does not need to know the implementation of the data type. And when they say user here, they mean the programmer. Abstract data types are created by programmers. Now, first we're going to be talking about structures which do not have methods. And when I say that, you can put methods in a structure. And when I say methods, I mean functions. You can put data and methods in a class. After C++ was invented, there was absolutely no difference between a structure and a class except one. By default, everything was declared private, and in the other, everything was declared as public. Terms that will either make sense to you Java programmers, but to those of y'all who haven't taken Java, not yet. So abstraction, the definition that captures a general characteristic without details. Example, an abstract triangle is a three-sided polygon. You might have specific triangles, scalene, isosceles, or equilateral. I know what an equilateral one is. I'm not so sure about the others anymore. Pardon?
Do you recommend Java after this?
Absolutely. Java is where to go after this. That is such a good question, and that's the answer. Also, C#.
Okay.
C# is an excellent sequel to this as well.
A special selected class, right?
Pardon me?
A selected topic class?
There is a C class being offered this summer.
In
Pure C, right, rather than C++.
Yeah, it didn't show up in the Oasis.
Oh, that's weird.
It was under like selected topics or something like that.
Okay, yeah, it is a pure C class, which is well worth taking, actually. It's going to cover some of the same stuff just because C++ is kind of like super C. But there are a lot of jobs that still rely on people writing in pure C. And why would they do that? Well, Linux, for example, the Linux kernel, the guy who invented Linux thinks, with some justification, that C programs can be written to be easier to understand than C++ programs. Now, at the level that we've been teaching this stuff so far, that we're learning, they pretty much are almost interchangeable. But once you start writing complex programs with classes and all sorts of object-oriented programming tricks, it can be hard to follow, and it can also be hard to predict how it will handle under every circumstance. And so he insists that the entire Linux kernel be written in C. And so there are a lot of C programmers writing for Linux, and that's not the only circumstance. C code compiles down to a smaller footprint than C++. And so a lot of people who are writing, machine controlling software that needs to run in a limited amount of memory, write it in C rather than anything else. Anyways, combining data into structures. So what is a structure or a struct? It's a C++ tool that allows multiple variables to be grouped together. You have a string called name. You have an int called age. Another int called weight, that kind of thing. So you give a struct is the keyword. You give it a name. And then between the braces, you list all the variables that structure is supposed to contain. And then you terminate it with a semicolon, unlike the rest of our code blocks. Not quite true. We had a do while block that had that quirk as well, needing a semicolon to close it. So a structure for containing student information. Every student has a student ID. Every student has a name. Every student has a year in school. It's odd. What does that mean? And then every student has a GPA. Let's write a structure that looks like that. So if you haven't already created your boilerplate, as soon as you walked in, you were bored, go ahead and do so now. I'm not going to even read it aloud. Bless you. New source file. All the usual goodies. System pause and then return 0. All right, so I want to define a struct. Name student. Struct student. Now it is by convention that all classes, which is a structure with functions attached to it, begin with an uppercase letter, as opposed to everything else we've talked about. And so students have names. Almost typed uppercase string, that's Java. And they had a nice looking little student here. Let me pop that open again. An ID and a GPA. I'm going to skip this year in school. Alrighty, so what did I just close? I hope I did not close my code. Okay, so int ID float or double GPA. I believe we could provide default values for these things. Let's find out. If you create a brand new student and you haven't given him a name, then he doesn't have a name. His ID is 0 and his GPA is 0.0. Alright, so we have a structure that represents a student. We could create one student object. We could create hundreds of student objects. Multiple fields of the same type can be in a comma-separated list, just like when you're declaring local variables. You can do int x, comma, y, comma, z. You could do the same thing in your code, right? If we had more than one string, you know, string address, comma, whatever, state, city, street address, city, state, zip, right? Those could all be strings, right? I'm going to delete that. But you could do it that way, just like you could in local code, in your as a local variable inside, body of code. So the struct declaration does not allocate any memory. Just because oh come on, why do I keep doing that? Just because we've allocated, just because we've declared a structure, that does not actually make any memory. We don't have a place to store a name yet. We don't have a place to store an ID yet. You actually have to create a variable of that type. Two ways. You could list the variables down here, student S1, S2, like that. Now I have some students. Ooh, that didn't work. Anyways, or you declare them down here in your code itself. Well, let's declare a couple students. Student S1, comma S2. And then S1's .name is Bugs Bunny. S1.ID, he's got a student ID of 1, 2, 3, 4, 5. Bugs is really smart, so he's got a S1.GPA of 4.0. Let's make another student. S2, well, we already have, right? We created 2 students. It's this step that actually allocates the memory so that we have a space to put our objects in. Now, you Java guys are used to having to do something like this. S1 is equal to new student, right? You don't do it that way in C++. Makes it look like it's easier to use, and as a matter of fact. But anyways, okay, so S2.name is equal to Elmer Fudd. You can tell I'm old because I'm not using cool cartoon character names, modern ones. All right, S2.ID is equal to 5, 6, 7, 8, 9. And then S2.GPA, he's almost as smart as Bugs, 3.9. I'm going to add some spaces to make this stuff look a little easier to read. All right, so we've created 2 objects. Both of them are of the same type. They are both of the student structure. I keep wanting to say class. We're going to switch over to using the word class pretty dang soon. All of these variables are known as public members of the class. Public meaning that you can access them in this fashion. But you can also declare private variables. Now, in the case of a structure, the idea of a private variable is extremely odd. But we could. Private colon, and let's create a private variable. I don't know what is so private. Is address, string address. What does that mean? It means that we can't access it from the client. s1.address is equal to 1, 2, 3. No, it's going to consider this an error. I'm going to wind up commenting this out because it was declared as private. So you have two keywords. You've actually got more than two keywords. You have the keyword public and you have the keyword private. So these are public variables, meaning that the client code that created the variable can access all of those. Some people call them fields. Can access all of these fields, all of these members of that structure. But the client code cannot access that field, cannot access that structure. Then why in the world would you do that? It makes a lot more sense when we start talking about classes. Now, by default, everything in a struct is public until it hits the private keyword. That's why I didn't originally create it with the public keyword. That's why I left that keyword out. Okay, I'm going to delete the private part because it's silly in this case, right? We couldn't change it, so I don't care. Okay, I think I'll leave the public keyword there, but I'm going to put a comment as this is the default for structs. Structs are typically declared in header files. I vote we do that. I vote we cut all of this stuff. Cut from the word struct all the way down to that line with the semicolon. And then let's open our Solution Explorer back up, and we're going to make a new file. Over here under Source File, add new item, but make it a header file. And then call it student.h. I'm making mine with a capital S. But it's a header file, so student.h, click add, and then paste. Oh no, I lost my structure code. Let me come back over here, undo it, copy it again, or cut it again, come over here and paste it into student.h. Alright, now we're getting into problems here. This header file doesn't know what a string is, so we would have to put our # include, string up here. May as well do that. This is really tacky. # include string. And then let's put this std : like that there. Why? Because it's really incredibly tacky to put using namespace std inside of a header file, so that anytime anybody includes that file, all of a sudden it's using a namespace that you weren't expecting. So that's why I did that. So that's what my header file looks like now. I'm going to go back and modify source.cpp to include that header file so that it, because right now my code's broken, right? If I come back over to source.cpp, can I get both of these loaded up at the same time? I know there's a cool way of, well, I could do it that way, but that's kind of lame. Anyways, if I come back over here, it doesn't know what a student is, right? So I need to add one more include. #. I'm sorry, pardon me?
If you hit the Windows key on whichever area you want, you can position whichever screen you want.
Yeah. Okay, cool. Include quote student.h. All right, I'm actually going to wander over there. I want you to show me what you just said. Right, but I wanted two code windows in the same editor. So yeah, you're right. You're exactly right. That's cool. And I keep forgetting those key combinations, so I just grab my window and slam it over there. Okay, so Now that I've done # include student.h, my code is working again. You should define your structures in header files. They can be shared between multiple .cpp files then. Although our projects have been simple and I have generally only had one .cpp file, in real life you're going to be working on projects that have 10 CPP files or 100 CPP files or whatever. So you're going to put these things in header files so that they can be accessed from multiple C files. So let's write something that does something with the student, like gets the information to fill in for a student. And we want it to fill in the student, so we're going to pass that student in as a reference, right? We could also do it as a pointer, so that that data will actually change. We've already kind of established that if you pass something in, as a parameter, as an argument, then that function can't change its data. But if you pass it in as a reference or pointer, it can. Now that's, okay, I won't give any more complications. I'll leave it at that. Okay, so void gets student. And we're going to take student ampersand for reference, st. So st is a reference to our student object passed in as an argument. All right, we're going to ask the user for the person's name, for their ID, and for their GPA. So cout, what is the student's name? cn arrow now st dot name. I said dot name. Do the same thing for the ID and the GPA. Write another pair of cout and cin statements. Cout arrow what is the student's ID? cin into st.id. Cout arrow what is the student's GPA? And then cin into st.gpa. Not std, st.gpa. Alrighty. So that place down there where we created Bugs and Elmer, right? We've already got some student information for them, but let's make a couple of more students and then call get student on them. So above that line that says student S1 and S2, it's not going to look right, but I'm going to make student S3, comma S4. And then I'm going to call, get student S3 and get student S4. Now we're doing that annoying thing where every single time we run the program we have to type data. So, but we'll deal with that. All right, I'm going to run the program. Rebuild solution. Did I have any errors? Nope. All righty, got a warning. Truncation from double to float. All right, if I hate that error, if I want to get rid of all possible warnings, it's complaining that 3.9 is a double and that GPA is a float. That's because this literal here, and in fact all literals defined inside your editor like that are assumed to be double unless you add an F to it. That turns it into a float. That would get rid of that warning. Do you have to do that? No, but it gets rid of the little yellow warnings in your error list. There, now I feel good. No warnings. Alrighty. So I run it. It's going to ask for... I'm sorry.
It will compile.
I broke something. Oh, I have a breakpoint there. All right, let me come look. All right, so I've gone too far without... Let me get the code back on the screen. All right, a couple of things that can get you. Cause syntax errors. One is that if you've written the header file, rather than using one that the C language gives you, you got to put it in quotes. Can't use the angle braces. What the quotes mean is grab it from my own directory. What the angle braces mean is that it's stored in the C library, directory structure. Well, your student.h isn't stored in Microsoft's library of header files. So that's why you do that. That's one thing. Another is over here in our header file, we had to do this, std::. We had to specify the namespace that the string class is in. Why? Because we did not have a using namespace std here. And why is that? Because it's poor form to put using namespace statements of any kind inside a header file. People generally expect that they can do, #include, and they get just the stuff that they're expecting, which is your structures and your classes and your constants, not any surprise using statements. So I had to put std::. there. The last thing that can give you a warning, at least, is if you don't put that semicolon there. You Java programmers are used to not having to do that when you define your classes. It's just a quirk of the C++ language. The reason why is so that you could create a variable right now rather than go and put it in your code. It would create a global variable of that name. And the way it knows whether there's a global variable or not is by whether there's something in front of that semicolon or not. Now, it's possible it'll compile without that, but it'll give you a warning. No. Missing a semicolon. All right, okay. Absolutely mandatory. All right. So if I run it, it's going to be asking me for some information. Excuse me. I wish it would keep these settings between. Right. All right. What's the student's name? Joe Bob. Oh, neat. Why? Because I entered 2 names rather than 1. Alrighty then. Let's run it again. What's the student's name? Joe. What's his ID? What's his GPA? 3. What's the student's name? Sam. ID. GPA. 3.5. All right, now we're not doing anything with that data, but at this point in time, we have 4 students. If we go back and look, I'm going to need to redock this. We have created 4 student objects, right? We created 2 there, and then we created 2 more that we filled in our code with literals, right? With Bugs Bunny and Elmer Fudd and some literal constants like that. We could stick those things in an array. Let's try that. Student slist for student list, or SAR for student array. 4. Now SARR subscript 0 is student 1, S1. SAR subscript 1 is equal to S2. SARR subscript 2 is equal to S3. SAR subscript 3 is equal to S4. Now I want some kind of variable that'll follow me around so that, as I process this, I know how many students I have entered. What I really should have done is I should have declared a constant to use that for. So above that student SAR4, I'm going to do const num underscore student with an S equals 4. That's my constant. Oops, constant int. Sorry. Const space int space num students equals 4. And then I'm going to take that 4 out of my declaration of my array and put num underscore students there. That's just so that if I use any for loops, you know, I can just do for I is equal to 0, I is less than num students, and print them out. As a matter of fact, let's do that. We're going to write a for loop that'll print out the names of our students.
Do you need to put an F on the S2 that GPA equals 3.99?
That got rid of a warning. It's not necessary, but if you write a variable with a decimal point like that, it's assumed to be of type double.
Okay.
And I define GPA as a float, so it was giving me a little warning. Oh, by the way, your double is being truncated to fit in GPA. Now, you know, a float can already hold numbers up, you know, that are in the billions or whatever, so why it needs to warn me that. But it is. It's doing a type conversion, and if I put an F there, it's saying, no, this number is a float, so don't give me any warning. Alrighty, so let's print those out. For int I is equal to 0, semicolon, I less than, all caps, num students, semicolon, I plus plus, and let's see out their first names. See out SARR, I should have picked a better variable name than that. Student array. SARR subscript I in subscript followed by ENDL. And I'm getting some kind of bugaboo here. What's this problem? Oh, because I didn't specify which variable to print, right? I just said print out that student. It doesn't know what a student is, but it knows that what student name is. So this should be SARR subscript I dot name. So now when I run it, after I enter all that data, it's going to print out all 4 students' names. I keep accidentally inserting a breakpoint here. A breakpoint is when you run it and it'll stop at that point. I don't know how I keep doing that. Alrighty, so what is the student's name? Frodo. ID 1, 3, whatever. GPA 4. What is the student's name? Sam. ID 4. GPA 4. Alrighty, and so our 4 students are Bugs, Elmer, Frodo, and Sam, or whatever names you used. So we've created several object references and we have stored them in an array, kind of tying together both chapters that we're looking at right now. I really need to get that file back in my editor. Yeah, there we go. Okay.
Hey.
Although it did let us see more on the screen at the same time by ignoring the... I'll remember that. Okay. We all good? We got any typos that we need to... Okay. Okay.
That's the undeclared identity.
So why are we talking so much about structures? Because arrays are great and all that, but they're even better if you can hold multiple chunks of data, right? And that's what a structure is. Otherwise, you're using what are known as parallel arrays, which is where we would have an array of names and then we would have another array of GPAs. And we would have another array of student ID numbers, right? And that's not really the way that our brains think. You know, you think I have a student and I have another student and I have another student, not, oh, I have a list of names and I have a list of GPAs. The concept of parallel arrays is important, and so that's something that you talk about a lot in Python classes and stuff like that. But the idea of stuffing an array with structures is also incredibly useful. And in previous semesters, I have not been emphasizing that enough. So y'all are getting the extra goodness. Alrighty, so use the dot operator to refer to members. Members are those variables. Called lots of different things. Different textbooks call them different things, but member variables. So name is a member of the student class. So this student here, student 1, has a member called name, .name. Member variables can be used in any manner appropriate for their data type. Since this is a float, we could do anything that we could do with a float. Since this is a string, we could do anything that we wanted to do with a string. Can be done to that member. So to display the contents of a struct, you got to use the dot. You can't just do, and this is what I did. That was my mistake, right? When I tried to print out the array or whatever, I just did, that. But I didn't actually specify the members. Now, if you're a clever programmer, you can write a class or a structure so that it can be printed with that fashion. You have to provide what's known as a overloaded stream insertion operator. But that's a bit beyond what we're doing here. We'll do stuff like that when we start talking about classes, probably on the last week. So comparing structure variables. You can't do that. If I went in here and I did, what if I created 2 students with the exact same information? I'm going to create yet another student. Student S5, and he's going to have all the same information as Elmer. I'm just going to make it say S5.name is equal to Elmer. All I did is copy that S2 stuff, right? S5.id and S5.gpa, they look like they're the same thing, right? The looks are deceiving. If S2 is equal to S5, let's print out that effect, that information. And as a matter of fact, it's not even supporting it. It's giving us an error, so I don't even need to finish writing the course here, the code here. That's of interest to me because Java would have let us do that. I like the fact, yeah, and Python would have let us do that. But in Python, it would have actually worked. Python's a cool language. Okay, no equal operator matches these students. We could provide an equal operator, which would let us do that comparison. But we aren't going to do that yet because we're not talking about classes. So if you wanted to compare them, you'd have to do something like this. If S2.name is equal to S5.name, and S2.gpa is equal to S5.gpa, and you can see why this is kind of annoying. S2.id is equal to S5.id. Then the students are the same. Have the same contents. So, until we know more, that's how you have to compare 2 structures. You have to compare their members. That gets tedious if you're doing it a lot, right? Sure, just a one-time comparison, okay, fine. But what if you had to compare several students in several different loops and you always had to do that? And then what if you added a member to the student class? They had a student year. Our student class doesn't have one. So if we went and modified our .h file to have a year member, we would have to go and modify all of our if statements to also check to see if student 2's year is equal to student 5 year. So this is not an optimal way of doing it, but it's how we know how to do it right now. To compare 2 objects, you can't just do S2 equals S5. You couldn't do that in Java. You had to use the .equals method. You could do it in Python, because Python's cool. Is that true?
I think Python would return.
No, in Python we had to create our own equals method before we could do that. Is that just about what you were about to say?
So Python's
It would return false.
Yeah,
Because
yeah.
they're not literally the
Because
same.
they're not literally the same thing. Okay, so in every language, you can't just compare 2 references like that. But C++ lets you override the equal sign to do something special so that it actually will compare the thing. In Java, you had to do a dot equals method in order to compare the two objects. And in Python, we wrote a underscore underscore eq underscore underscore method in order to get that to happen. Don't you guys who haven't taken Java like that I'm talking about it all the time? But some of y'all have, you know, at least 20, 25% of y'all have, so that's why I mention it. And the rest of y'all are gonna take it. I'm sure of that. Okay, so I hope so actually. Good programming language. The more programming languages, if you learn one programming language, that's okay. If you learn two programming languages, that's awesome, because by then you have an idea that the same thing can be accomplished in multiple different ways. You know, and then you start tacking on others. Initializing a structure. You can initialize a structure like this. You have to define these values in the same order that they are in your structure, right? We have a name and an ID and a GPA. So we couldn't do this, right, because that makes the name the second one, but it was the first one in our structure. So let's make still yet another student. I'm going to go back to my project. I'm going to make a student S6, but I'm going to initialize it with some data. So, Donald Trump. He wants a student ID of 1, and he wants his GPA to be better than everybody else's, so he's got a GPA of 9. Alrighty. Now I've made a mistake there. It's not liking the fact that I have a colon. So I've done something wrong. Do I have them in the wrong order? This was not intentional. And we actually got this to work last time, so I wonder what I've done wrong. Nope, I'm not seeing it. Well, if it's not going to work, okay, let me go back and look at this slide again. Well, I'm not getting it.
I think if we should just say Donald.
Yeah. What if it was, okay. Is that good? What happens if we delete all of that? Is that going to work? All right. Nothing is working. It worked last Tuesday. It's not working today, so I'm going to punt on that one.
Is that because it doesn't have any input variables in our struct, so it doesn't know what to feed it into?
You ought to be able to do it without creating a constructor. And was that what you were suggesting? Remember how that
So like how stuff doesn't have any input variables in it.
Right, but we should still be able to do it. If you look at their example and how they're filling it in, if we copy their example exactly, I bet it would have worked. If I had done this, whoopsie. Here's how they define their class. Up here. Where's their student definition? Like this. And then that's how they were initializing it later. All right, I'm annoyed that it's not working. We're going to mess with that concept. I'm going to delete this line, though, since it's not working. But I'm going to define another structure that is simple. All it's going to have is one number. That's dumb, but it's all it's going to have. So above main, struct dumb. And all it's going to have is one int in it. And then the first thing that main is going to do is dumb d is equal to a 0. Now that worked. So why didn't our structure work? Don't know.
Maybe because Donald's.
Is it because you put predefined values in?
Is it because I put predefined values? Let's go and remove our predefined values in our structure. Very good theory.
Because I was hovering over my bracket, it says argument types are constant character and then a bracket with one range.
Alrighty, that may be it. So down here, student S6 is equal to angle brace, quote, Donald, comma, ID1 with a GPA of 9. I bet you're right. That looks perfect. Well, what do you know? I don't know that.
Do not know what.
That I could not use this syntax if I had defined values like I did here. If I want that initializer list to work, I better get rid of my default values in here. And honestly, can't explain why that's the case. I'd have to look at the error message it was giving a little more closely and Google it up. No instance of constructor matches the argument list. Okay, so we could make a constructor that would do it, but we can't initialize it with that primitive fashion. Okay, fine. Whatever. Take that away and it works. Awesome. Thank you. You rock.
Take the values away?
Yeah, in our header file, don't initialize our data the way that I was doing. Just make it string name, not string name is equal to empty quote. And instead of ID equals 0, just make it ID in GPA. So, you can create a structure in one fell swoop like that with an initializer list. We also saw that you can do an array like that. Or you can do members by member, right? S.name is equal to somebody. S.gpa is equal to that. Now this is far more common. How often do you already have all this information, you know, in real life? No, you're going to create an object and then let it get filled in from user input or reading or something like that. Arrays of structures. So your structures can be placed in an array. You can use these in place of parallel arrays. Okay, guys who haven't had me in other classes, have we talked about parallel arrays yet?
I forgot.
It's about time to jump out of this subject and to start talking about parallel arrays. So, we're going back to chapter 7 where we should be. Not chapter 7 of the Python class. Try once more. Alright, so here's an example of initializing an array, just like you did as a list in Python. Looks very similar, except in Python you didn't have a data type and you didn't use this symbol. When you declare an array, if you initialize an array in C, C++ with an initializer, you can specify the width of the array, the length of the array, or you can leave that out and it will do it automatically to the size that is specified here. Now you can't do something smaller, right? Can't fit 4 items in 3. But you can make this larger than the numbers of the initializer. And if your initializer only has a certain number of items, but it's actually an array of a larger length, the rest of the items would be filled out with zeros. So if we had this, like this, I want 4 quiz grades, but we only provide 2 of them, then it would say 12, 17, 0, 0. The idea behind parallel arrays is that you have 2 arrays or more of the same length. It's very important that they be of the same length, where the items are related by their index number. That's kind of like a spreadsheet. If we pop open Excel, we could type in list of data. Something like this. I'm going to add some element numbers. This is the index number, and this is going to be an array called name, and this is going to be an array called heights. All right, so Joe has a height of 6.2 feet, 6.3 feet. Bob is shorter, 5.75 feet. I can't type. In the meantime, Susan has a height of 5.9. Jim, pretty small, 4.8 feet tall, 4.9 feet tall, whatever. Okay, you get the idea, right? We have two arrays, but they are related to each other by their index number. And that's, you know, exactly what spreadsheets do, right? Every time you're adding a new column, it's related by its row number, right? Everything on row 4 is probably going to be, you know, of the same thing. So like you could have your months and you could have your sales for that month. So in January we had sales of $100. In February we had sales of $120. In March we stayed home. We didn't have any sales. And in April we made up for it by doing a bang up job and sold $500, right? And so these items are linked by their index values. That would be index value 0, 1, 2, and 3, just like in all of our other arrays. We start counting at 0. We could have more columns, right? I don't know what. Sales versus the costs of doing those sales, right? Cost $80 to buy our stuff, and we sold $100 worth of stuff, so we made a profit of $20, right? And then in February we sold $120 worth of stuff, but it only cost us $40, and so our profit was $80. If you didn't sell anything and you didn't have any costs, great. In April we had 500, but our costs were 520, so we're bad. We're in the hole. Okay, like that. Now we have 4 parallel arrays. They're all linked by their index number. So let's create a couple of parallel arrays. Let's go back to our code, but let's add this stuff up to the top. Oh, I cannot believe I quit C++. Okay, what am I going to do? I'm going to do open recent projects and find my last one. Because if I just double click on a CPP file, it doesn't work. Okay, so go up to main and let's create some parallel arrays. We're going to create some item names and then the colors of those items. So they're both going to be strings. String names, and we want 4 of them. Now we're going to initialize them, so I'm going to leave off the number. But I should define a constant, right? So yeah, okay. So constant int num underscore items equals 4. And then string names, square brackets, num underscore items. Now let's pick some names. What are our objects that we sell? We sell sleds. We sell sledgehammers, just hammer. I'm going to make these all singular. Sled, hammer, chair, and a top. Now let's pick some colors. We're going to define another array of num items linked called colors. And we're going to initialize them to different values. So string colors num underscore items is equal to curly brace, and remember I just break these things up. You can put them all on one line. We have a red sled. Our hammer is black. Our chair is white, and our top is painted green. And now let's get our quantities. How many of each one of these do we have in stock? String QTY square brace num items, and we've got 10 of every one of those. 10 comma 10 comma 10 comma 10. except these aren't strings. They should be numbers. I'm sorry. Change the data type of quantity to int. Now we're going to write a for loop that'll print out our current inventory. So firstly, just build and run it to make sure we don't already have any syntax errors, because we know the for loop's not going to work if the rest of the code's broken. Okay, so it's working for me. Y'all build it too and make sure. Wave your arm if you're having problems. You okay, Daniel? Or you need me to come look? All right, let me come look. So, parallel array, arrays of the same length, where the items are related by their index number. So we want to print out our names and our colors and our quantity. So we need a for loop. For int I, and I always use I, meaning I'm iterating through an array. That's just why I use that. For int I is equal to 0, I is less than, not less than or equal to num underscore items, I++. And we want to see out all this stuff. So see out qty subscript I, and then arrow, quote, \t. Remember the backslash is one above the enter key, not the one under the question mark. And now let's print out our second item, or excuse me, our second array. See out arrow, the color of it. Colors subscript I, and an arrow, quote, \t, and then one more. See out arrow, the names of the items. Names subscript I, arrow, \t. Could you have done all that in one line? Sure, you could have. And then lastly, ENDL, right, because we're done. So when we run it, it ought to say, 10 red sleds, and 10 this, and 10 that, and 10 the other. There we go. I have 10 red sleds, 10 black hammers, 10 white chairs, and 10 green tops. So I hope you get the idea of what parallel arrays are, right? They're thematically linked by their index number. We have 10 red sleds, 10 black hammers, 10 white chairs, and 10 green tops. What would be really cool is if we had a structure that had a color, a name, and a quantity. So we're going to define a structure like that, and then it's going to be the last thing we do for today. So, assuming you got your for loop right, even if you haven't, I'll help you with it as soon as class is done. Let's go above main and define our inventory structure. Struct INV for inventory. And so names are strings. So string name, colors are strings. String color, quantities are numbers. We can make them ints, we can make them floats. I have 3.5 hammers. I'm going to make them ints. Quantity. And then when I want to create one of these bad boys, INV I1 for item 1 equals, a wagon, and it's red, but I only have 2 in inventory, and that should not have quotes around it. Right? And I could create 4 items like that and stick them in an array. That is actually a more natural way of thinking about things in a way. At least I think so, but I've done object-oriented programming. You create 4 inventory items and you place them into an array rather than have 3 arrays where your data is broken apart into several lists. Both are perfectly good ways of handling data like this. If you start doing database programming, you're probably going to see more thinking like this, right? If you ask a database for a bunch of records, a record is in effect an object or a structure rather than, so if you say, I want everything that was sold on this day, it's going to give you a list of records, which is a list of structures. It's not going to give you 10 different arrays, and you have to piece the data together yourself. All right, let's make a Dropbox so we can call ourselves done, and if your program isn't running at this point, well, how would I know? I haven't even run mine. Okay, I did, but not since I created the inventory. All right, just to make sure, what is the student's name? Joe, ID 12, GPA 4, Bob 13, GPA 3. All righty, and there we go. Okay, great. It is working. So this will be Dropbox R. We still have homework out there for you to do, so I feel okay about not giving you another assignment.
So the last day to do quizzes is like finals day,
Yeah, you can keep retaking them up until finals day, right?
and it's not due till finals day.
Oh, I would get them done early so that they can be graded early so that you could take them a second time. Yeah. All right, guys, refresh your Dropbox. You'll see Dropbox R. We should be good to go. Go ahead and give me your header file and your CPP because we have two files that we created, right?